Welcome, Padawans, to the Jedi Master-piece Theater. This is Organic ISP Series number 6. We're going to be talking about Cycloalkanes. This will be the last alkane lesson for the ISP series, and it's a relatively short and simple one. We have alkanes that are wrapped into circles. So the smallest chain length that we can actually wrap around into a loop is 3 carbons. Right? So generally we end up drawing cycloalkanes as geometrical shapes. We can start with the triangle, square, pentagon, hexagon, and so on. And all we have to do in order to name these is we're going to use the same name as the usual chain length. Okay? So this would be a propane, butane, pentane, and hexane. The difference is that if we wrap it around into a circle, right, we're going to add the prefix cyclo to the front to indicate that it wraps around and bonds to itself. Right? So this would be cyclopropane, followed by cyclobutane, cyclopentane, cyclohexane. So the very basic naming structure, it's easy, right? We're just adding cyclo to the front. And the number of carbons is actually, I think, easier to determine because when we recognize these geometric shapes, we immediately know how many points are on the shape. It's easy to see that there's 3 points, 4 points, 5 points, 6 points, and each point being a carbon, right? We immediately see that that's 3 points propane, 4 points butane, 5 points pentane, and 6 points hexane. And even in some cases, right, the name of the shape, like pentagon and hexagon, has the same prefix as the prefix for the number of carbons. Right? So the only other thing to deal with at this point is what if we put branches on our cycloalkanes? So we can start with any cycloalkane we like. For example, we'll start with cyclopentane. And if we decide we're going to put a branch on it, let's just start with a simple methyl branch. There's 1 carbon coming off. We're going to use the same rules as we did before. We determine the longest chain length as our main chain. And in this case, since we have to choose between a cyclic chain and a linear chain, right, we're going to count the number of carbons in each. So obviously this is going to be 1, 2, 3, 4, 5. And there's only 1 carbon in the linear methyl chain. So our main chain is going to be cyclopentane, and we're going to name our 1 carbon methyl chain as a branch. And in this case, we can just call it methyl cyclopentane. The reason we don't need to number it is because since there's only 1 branch, right, that 1 branch can only be really in 1 position. All the positions around the ring are equivalent. I could really number this starting at any position, right? So I could call this carbon 1, 2, 3, 4, 5, right? Or I could call this carbon 1, and then it would be 2, 3, 4, 5, or call this carbon 1 and be 1, 2, 3, 4, 5. And of course, with our rule that we're always going to use the lowest numbers, if there's only 1 branch, then it has to be on carbon number 1, right? We have to number it so that number 1 is the branch that the carbon is on, right? Then we can ask, well, what happens if we put 2 branches in? Right? So if I put a second branch, say, over here, right, and it has 2 carbons. 2 carbons is still less than 5, so our 5 carbon cyclic chain is going to be our main chain. Ethyl is going to come first alphabetically, then methyl, and we have to decide is it going to be 1, 2, 3, or is it going to be 1, 2, 3? Right? We know that the branches are going to be in 1 and 3. Right? If we were to number it around this way, it would be 1, 2, 3, 4. Right? So obviously 1 and 3, right? Are 3 is lower than 4. So it's the first point of difference, is they both start with a 1, right? But if we count around this way, it becomes 1, 3. If we count around this way, it becomes 1, 4. Right? So in this case, we have to decide, well, do we make the methyl carbon 1 and the ethyl carbon 3, or do we make the ethyl carbon 1 and the methyl carbon 3? In this case, because the numbers are the same either way, we just use the alphabetical order, right? So whatever comes first in alphabetical order, right, is also going to get the lowest number. So since ethyl is going to be coming first, we're going to call it number 1, and then that makes the methyl group carbon 3. So we're going to call that 3-methyl with a 1-ethyl. So this is going to be 1-ethyl, 3-methyl cyclopentane. Okay? So we're really just employing the same rules that we employed with linear alkanes, just now we can wrap things up into a cycle. Right? So now there's the second scenario. What if our cyclic group is shorter than our linear group? So let's start with a longer linear group. 1, 2, 3, 4, 5, 6. And we'll put, say, a 3-carbon cycle coming off of it. Right? So now we have 1, 2, 3 versus, if we count it from this side, 1, 2, 3, 4. So we're going to number from this side, so we get the lowest number is 3 for our branch as opposed to 4. 4, 5, 6. And this is going to be a 1, 2, 3 carbon cyclic branch. So since 6 is longer than 3, we're going to make hexane our main chain. And since our branch is a cyclic group, it's going to get the suffix -il, just like methyl, ethyl, propyl. Right? So it's going to be a cyclopropyl branch. And it's on the 3rd carbon of our main chain, so we're going to call it 3-cyclopropyl hexane. And I think that pretty much covers all of alkane nomenclature. So coming up in lesson 7, right, we're going to start talking about functional groups. May the force be with you.